Yes, I'll just make a new one. So anyhow, this is called a quadratic lookalike. And anyone have any thoughts on how we could even attack this? It's a quartic. Like I've never asked you to factor, I don't think, a quartic before. Any thoughts on where we could even begin?
Would you just do 4 cents?
You wouldn't. Good thinking, though. It would be. So really, we're going to just follow the same template. It's just, and you'll see right away why we call it a quadratic lookalike, because it really, it follows, and I'll show you what I mean in a second. I was interrupted by the phone, but there's a way to check to see if it's a lookalike. But in the meantime, let's get into doing what you guys said. And that is, I know that if I put an x squared here and an x squared here, that I can at least accomplish mission number one. And mission number one is this yellow connector. And if you think about that, well, you know that x squared and x squared multiply to make x to the fourth. So we can check that off our to-do list. But what's also nice about putting those there like that is now if I just follow the same ideas that I've already used before, it's to say, hey, I'm just trying to make a negative 24 here. I can think the same way. I can still put in a +3 and a -8. And then again, just kind of watch. Well, you know this, like the blue connector is a no-brainer. 3 and -8 make negative 24. But the real interesting sort of magic-y part is what happens here in the center. These red ones make what? Right, 3x squareds. And what do these green ones make? Beautiful. And so we kind of forced those like terms to happen. We forced there to be a 3x squared and a -8x squared, which if I combine like terms makes, hey, jackpot, -5x squared. So that is just in a very simple level how you factor a quartic, what we call a quadratic form or a lookalike. And the way you can spot what I was going to say before my phone rang was that the way you can spot a lookalike is right away to look at the exponents. This part of the lesson is really important, so follow along. Notice that the highest power is 4, and notice that the second highest power is exactly half of that. That's what makes it a lookalike, is when you have x to the something, and then the next term is x to the half as much, right? And so on a grander scale, I could even do something like this. Is it a lookalike? It is. It meets that criterion. It meets the criterion of having a high power of x and an exactly half as much power of x. That's what makes the magic happen, is that I'm then able to just divvy up my x to the 10th, put half of them here and half of them here, and then it's just factoring 101 from this point. Yeah, man. Nope. Nope. Actually, where this lesson goes from here is GCFs will come into play, and then we'll also, like we did last week, see offspring creating offspring, right? It's an interesting question, but no, I don't see that coming. So same as before, and now I'm just looking at my basic facts. I just got to make negative 28. How do you multiply to make negative 28? Definitely a -4 and a +7. So, and again, you can just see it happening. Like, I hope by this point it just makes sense to you. Look, the gold connectors make my x to the 10th. Perfect. My blue connectors make my -28. But the magic is the red and green are both now like terms. -4x to the 5th plus 7x to the 5th makes my +3x to the 5th. All right, good. How about this one? It's Sam again. I'm sorry. All right, Bryn, I'm ready for you. What you got?
Squared +3 and then x squared.
Now, as I alluded to about 2 or 3 minutes ago, this isn't going to be the stopping point a lot of times. And so do you notice anything?
The second one
The second one is the difference of two squares, right? And that becomes just like last week. Now, part of your responsibility is to identify, can the offspring now produce more offspring? And so in the previous examples, I haven't wanted this to happen yet, but at this point now I'm going to start chucking it in there. Your job is to say, hey, you, red underlined guy, are a factorable expression. So my final answer is going to be my unfactorable x squared plus 3. That's just a sum of trash. It means nothing. But what does x squared minus 9 factor that into? X, right, x one of each 3. Yep. Still good? Okay. I have like 4 or 5 more. I just wrote these last night, and I thought that each one uh, had a purpose to serve. So I already see what the purpose of this one is. So that's just a basic look-alike, right? Look at those powers of x, 4, 2, nothing. That's perfect pattern for a look-alike. So we begin the factoring by building our shells, and in the front of each one, of course, goes my x squared. And now it's just basic factoring. Can I do my basic facts? What are we going to put in there? Good. Again, good basics. We know they both have to be either both plus or both minus because they multiply to make positive 9. But we also know that they both have to be minus because they add to make a negative in the middle. So what do you notice this time? No cubes. But interestingly enough, that is a difference of squares. And even more interestingly enough, that is also a difference of squares. And so I'm color coding this for your educational convenience, but notice that the red underlined one has its own offspring and the blue also has its own offspring. So this one, Bryn, you were sort of foreshadowing a while ago, does actually wind up having 4 sets of parentheses just because it does. So what are my red ones going to be? And what are my blue ones going to be? Right. And no matter what order you guys say them to me in, I'm always a put the plus before the minus guy. So just for the record, I'm never trying to like poo-poo your input. I just always do mine plus minus for difference of squares. So, still good? Okay, so now we're going to just kind of do the last level of this. The last 4 examples all have something in common. Would one of you shut the door for me? Just put the blocker in and give it a good shut. Thanks. You can. So now the rest of these examples will all have a GCF. And so we're not going to go anywhere until we get that out. Right away, you know something stinks because it doesn't fit the mold. It doesn't meet the mold of the lookalike. It doesn't have x to the something and then x to the half as much because like 3 is not half of 5. But I do notice that they all can be divided by x. And so I'm going to take this x that's in common to all of them, and I'm going to pull it out front, and I'm going to rewrite the problem. What would x to the 5th become? What would minus 9x to the 3rd become? And what would plus 20x become? Good. And so as you saw last week, right, you know how this works, is there's a math problem that we want you to do, but it might hide under a layer of GCF. And the layer in this case was pretty skinny and wimpy. It was just a little x. But once we get it out, we now identify that this thing I'm underlining in white, that's the actual math problem I want you to do. So when I write my final answer, I'm going to keep my GCF. Remember, he doesn't go away. And then I'm going to build my 2 shells. What are they going to say? Good for you. Perfect. Good. All that hard work is paying off. You guys just are recognizing things. X squared minus 4, you see it from a mile away. He's a difference of squares. So the thing I have underlined in blue is going to produce his own offspring, but I do have to keep track of everybody else. The GCF is still present and accounted for, and the unfactorable x squared minus 5 is still present and accounted for. And what are my little blue guys going to be?
minus 2x.
That's it. Okay. Still good? Okay. Next one. Can I scroll up? Does everyone have that last example down? Peyton, you good? Okay. All right. So here's our next one. Three to go. Yeah. In fact, not only are you allowed to switch the order, you need to. So that this example, along with the next couple, serves the purpose of reminding us that not only do we look for a GCF, but we got to put stuff in the right places. So like we're not going anywhere until we achieve that standard form. Like x to the mostest goes first, and then x to the mediumest goes middle, and then x to the weakest goes last. So like Alyssa said, as long as we keep the signs intact, that's what's key. So our negative x to the fifth is going to move to the front. So negative x to the fifth. I wouldn't do multiple steps at once if I were you. I just wouldn't. I wouldn't be comfortable with how it's all going to shake out, and you'll see that in a minute. So negative x to the fifth moves to the front. Who's after negative x to the fifth? Yeah, definitely the plus 5x to the third. And then wimpy goes in the back. So that's going to oftentimes be step one, is get it rearranged. Don't do any real math, just fix it, like make it look right. And now it's GCF time. What is the GCF? It is negative x, and that's really important that you factor the negative. Whenever you're factoring a polynomial and it starts with a negative, you should factor a negative, even if that's all you factor. But we can get the negative out, and we can also get an x out. And now let's be mindful. I'm actually going to get to that in a second. Right now, the only negative that I'm worried about is pulling it off the front. And then everyone else will kind of pay the toll as we go, Jared. So I think maybe after we do this next step, you'll see what I mean. If not, let me know. So we pulled out a negative and we pulled out an x, and now we have to rebuild the math problem. Again, don't bite off more than you can chew here. Don't try to do this and also factor it down at the same time. Terrible idea. So what does negative x to the fifth become if we pull out his negative and one of his x's? He's positive x to the fourth. Now, Jared, here comes the answer to your question. What becomes of plus 5x to the 3? He switches to minus 5x to the 2. So you see what we're doing is we're compensating for pulling out the negative at every step along the way. If you pull a negative, you're pulling it from everybody. And finally, what does minus 4x become? Plus regular 4, because now his x is gone. Jared, did that answer your question? Okay. So I'm only pulling the negative if the term in front is negative, and then everyone else will offset that by switching their signs. And then, of course, you see the actual math problem that we wanted you to do, and it's what's in the parentheses. And so the GCF is still present and accounted for. And then we're going to build our two shells. And of course, we're going to put x squared and x squared. And of course, they're both minuses. And what are we looking for numbers? 4 and 1. Good. They can both be, right. So both of those white parentheses, those binomials, are their own differences of squares. So we're going to wind up with actually 5 factors in this case. My negative x is my first factor. And then I'm going to wind up with the offspring of x squared minus 4 times the offspring of x squared minus 1. So this thing is very factorable. You break the dickens out of this thing. So what does my first one break to? X plus 2, x minus 2, and my second one is x
plus 1.
Right, so that's a very, very factorable expression. Everybody still feeling good? Okay, 2 more. I think you've got this pretty well. Next one is negative x to the fourth plus 3 minus 2x squared. What do we do first? rearrange that thing, right? So step one is to fix it. Negative x to the fourth. Don't factor it while you fix it, just fix it. It's like 5 extra seconds. Minus 2x squared, and then boot the plus 3 to the back. What is my GCF this time? It is just a negative, right? And you can put -1 if you like. I'm going to factor it out, honestly, as just a negative sign. And then I'm going to rewrite the whole problem. I'm not factoring, just GCFing. So what are my three terms now going to say? Beautiful. And now the white parentheses are the math problem revealed. So copy down your GCF, which is just a big dumb negative sign, and then build your two shells. X squareds go in the front. We know we need one of each, one plus and one minus. Definitely need a +3 and a -1. And done? Certainly not. Great job. You guys were all over that, like white on rice. Good job. So I still have my negative. In the order that you put these in, someone's going to want to ask, like, does it matter? Nope. So you can put the factors. Remember, multiplication is what we call commutative. That means that you can write multiplication in any order you want. So the factors, as long as they're all present and accounted for, it doesn't matter. So like I can keep my ugly factor, my x squared plus 3 can go first, and then the offspring of the difference of squares can go next. You could jumble them up all you want. Now, honestly, putting the negative anywhere other than the front would be a little creepy, but the other ones, you're welcome to scramble them up if it just happens that way. All right, last one. You guys are kicking butt. I don't think you're struggling with this one bit. Let's do -24x plus 2x to the third plus x to the fifth. ¿Qué tenemos que hacer primero? We're fixing it, right? Rearranging this bad boy. What comes after x to the 5? Right. Good. Again, just one thing at a time. The next thing we're going to do isn't real factoring. It's just pulling out the GCF. What is the GCF in this case? X. That was an excellent answer. And what does that, sorry, what does that leave me with? Done. And now we actually factor. So we're going to leave our GCF present and accounted for. And we're going to build our two shells. Stick your x squareds in the front. Factoring 101, of course, you need one plus and one minus. And what are the magic numbers? +6 and -4. And for the fourth or fifth time in a row, I really obviously wanted this to be a focus of the lesson, is watch for offspring that can produce offspring. I'm not trying to insinuate that that will happen every time, but it does happen a lot. And so clearly the x squared -4 is what we're interested in. And so the order again is irrelevant. I keep my GCF, I keep my ugly unfactorable binomial, and then of course I create the offspring +2, -2. Done. Do you have questions? This assignment is in the Delta Math. It is assignment number 28. And I don't think based on that you're going to have any issues, but oh, do I love answering your questions. So let me know if you get stuck.